Ooh.
Cons.
Ooh, he's so close. He's right. It starts with a C. What did we call this type? Yeah, coincident lines. How many solutions do these have? Infinite. And these are the same line. So their slopes would be the same, and their y-intercepts would also be the same. Is it possible for two lines to intersect in two places? Show me.
Two lines intersect in the same place?
No. Is it possible for two lines to intersect in two places?
Yeah.
Show me.
Like this line is going to be a coincidence.
Oh, but not just two. That's more than two, right? Is it possible to get them to be exactly two? No, you'd have to curve one of them, right? And they can't curve. Okay, so two lines, no. So those are your only three choices. No solutions, one solution, or infinite solutions. What type of lines produce the most solutions? Coincident. Coincident line. I wish I had, where is Shane? Shane needs to be here for substitution because we're going to talk about substituting in a basketball game, and he plays basketball. We'll get started, then I'll use him. Santos, you're going to be maybe my stand-in. So today we're going to learn some algebraic ways to substitute, and the best time to use substitution is when one variable is alone. When one variable is alone. What's wrong? What? There's a spider?
Yeah, it's like...
No, I'm scared of spiders. What?
It's on like a web.
Is it coming down the ceiling, Chloe? Okay, we'll fix it in a second. We don't want you to be distracted. When one variable is alone, or close to being alone, but pretty much, I don't know, Mrs. McDonald, would you add anything different to that?
When one variable, just when one variable is isolated, and I do have, I have a couple of examples that are.
Ooh, good. Write them down right here. Here. And I'm going to address the spider while you're doing
Oh,
it.
you protect them.
It's like right there.
It's very little.
It's really small, it's not.
This is traumatic.
Oh, it's here, it's very, Chloe, it likes you.
Where is it? Oh. Oh. Kill it.
It's literally really small. You can just flick it.
This is a sad, sad day.
Stop on it. Why'd you let it go?
It's out the hallway now.
So what else is it?
It's on the floor. Survival of the fittest. We'll see if it avoids the traffic.
So, sorry.
Okay, go for it.
All right,
Focus
so-
now.
Let's see, best when one variable is alone, some examples. This,
We can't see it.
well, that's a bunch of balderdash. Can I,
You can do whatever you want.
what the heck, this is all,
I know, I don't like that document camera. It's very finicky.
What's finicky?
It's just super sensitive, like this
oh,
camera.
there we go. Okay, I just,
It was really sensitive.
it's slow. All right, so a couple of examples of what we're talking about when the variable is by itself or alone. Whoops. There's an equation with a variable alone. The other one doesn't have to have a variable alone. What we see is that we know what the y is, so we can substitute, and Mrs. Conray will get into that, into the y in this one. Another example is another one that I had written down on my notes. is this right here. In this case, the variables are isolated in both equations. And then, because I've already done your assignment, I caught a couple of others. I caught another type where we have, but the variable wasn't by itself. Just a second.
It was an expression by itself.
Bear with me. Yeah, it was an expression. Yep. So let's say you had 3x equals 18, and then here you had 3x plus 7y equals 25. Why do you think this one does not have a variable isolated, but it would be appropriate to use substitution? Why? What do you see there? Just
No
look
Y.
at it for a minute.
There's no Y.
No, there's a y right here. Oh, you mean there's no y here?
Yeah.
Okay, but a little bit more than that. You're right. That is something, but there's a little bit more than that you see. What's isolated?
Yeah, but
The
what's
what?
in front of it?
Okay. Yes, so when we say when one variable is alone or isolated, is a variable isolated here? No, because it's got a 3x. However, what's different about this one? What do you see there? Aubrey, did you see it? Because you had your hand up.
She's gonna say 2 variables.
Okay, there are two variables. There's an x and a y.
Hold
If
on.
you do want that. But what do you see? Just look.
Oh,
You might think it's nothing, but it's something. What?
this is honey.
Huh?
Yeah, this
Okay,
is
there's something else I'm looking for you to say. Michaela? Well, we do have the 25, but I'm still, right here, we said, yeah, we've got a 3x all by itself. The variable's not really isolated, because we'd want it to be 1x to be by itself. But we do have 3x by itself. Why in this case is it actually pretty easy to substitute? What do you see in the bottom equation? Look for that. What do you see?
I'm gonna say it another way. If
Yes.
3x equals 18, what can you put in the bottom equation? If I said 3x equals 18, what can you put in the bottom equation?
You can substitute 3x for 18.
The way you were looking, I don't know if you noticed that I was looking over there at you a little bit more. It's because the way you were looking at this, I knew you were thinking about something. Yeah, that right there, because 18 is the same as 3x, we can put that 18 right here. And that makes it actually, we would take that 18 and we can put it right here. And that's just a nice little two-step equation to solve. That's no big whoop. If you see those things, the problems get easier fast. There's fewer steps that you have to do.
Okay,
This is a nice pen.
Shane,
Might steal that.
thank you for returning, because I need you to tell me, how does a substitution work in basketball?
What are we talking, just in general, or like?
Yeah, in general, what's going on? There's 5 players on the floor.
The coach call you up, okay?
Yeah,
You run the check-in,
you want to check it, and then what?
tell them your number.
Okay.
Knee down,
Okay, now what happens?
then the ref blows the whistle.
What happens?
Sub, and then you sub up.
You sub in,
You sub in for somebody.
and can they stay in?
No, the other person.
Oh, they have to go out. Okay, so substitution, when you're substituting, you're putting something in the place of the other and it comes out, okay? So what I mean by that is this. Do you see how y equals 2x plus 2 up here? What I'm going to say is, what does equals mean? What does that mean? Yeah, tell me in your own words. What does equal mean?
Equally.
The same. You can use either one. They're the same thing. So if I'm telling you y is equal to 2x plus 2, what you're going to do is you're going to substitute out this y down there. He's coming out of the game. What's going in its spot?
The Y.
What y equals up here? So in this spot, the y comes out, and I'm going to put in this spot 2x plus 2. So now I have 2x plus 2 because that's what y equals up there. And that equals negative 3x plus 4. Santos, write this down. Now we have an equation. Our equation has just x's in it. Let's solve it. Let's move the x's to one side. Tate, what should I do first? Combine like terms. Let's move this negative 3x to the other side. So I'm going to add, pay attention, some of you weren't very good at solving. This is your chance to recoup some of that. I'm going to add 3x to the other side. Now I have 5x plus 2 equals what's left on the other side.
Why don't you do both of them at the same time?
What's left on the right side? 4. Oh, we're on page 6. Okay, now what? Trying to solve for x. Subtract 2 from both sides. 5x equals, what's 4 minus 2? 2. Last step. What do I do?
You divide it.
By 5. Okay?
I don't know what that is.
Okay, well, somebody tell me what that is. X equals 2/5. Oops, not 2/3.
That'd be like
You can tell me what that is as a decimal.
0.73.
Okay. Now let's remember, we are really solving, these are lines, we're solving where the lines meet. So it's an ordered pair. I found the x. What do we still have to find? The y. So go back. Now you can use either equation because they're both the same. They mean the same thing. We're finding where they meet. And substitute the 0.4 in for x. I'll use the top one. So we would do 2 times 0.4 plus 2. What is that? Lucas? So 2 times 0.4 plus 2. Yeah, what is that? 0.8 plus 2 would be 2.8. Very good. So make sure you list the whole thing. The ordered pair, you can just circle the x and the y if you want, or if you want, like yesterday, you can write it as an ordered pair. That is up to you. Okay. Let's try another one. Yes. How did I get that? This? This one? So I found, you got how we got this? Okay, so I found the y because it says y equals 2 times x plus 2. I now know what x is. So I plugged it in for the x there to figure out what y is. So once you find the one, then you can plug it in to find the other. Let's try number 2. What variable is isolated in number 2? There's two lines. Which one is isolated? No, variable.
Oh.
Isolated means alone. Anthony. Y. Y is alone. Okay, so I'm gonna highlight the y down here. We're substituting. Y's coming out in the bottom. This y is coming out of the game. What's gonna go in y's spot? X minus 7. So here's what I write. I write 2x. Normally there was a minus y, but I'm taking the y out and I'm putting in x minus 7. Somebody tell me why I had to put a parentheses there. Because I'm subtracting y, I'm subtracting the whole thing. So I have to subtract the whole thing, x minus 7. What y equals. All right, let's keep going. Now we solve. I distribute, so I have 2x minus x. What does minus a negative give me? Negative x, good. Now I want the negative, I want it to go to the 7. Minus a negative 7 would be plus 7 equals 12. Michaela, tell me something I can do. I'm solving now. I'm trying to figure out x.
Combine.
Let's put these together. What's 2x take away 1x? 1x. Don't make that silly mistake and say, oh, the x's, no, they don't go away. This really means a 1x. Okay. Last step. Santos, what should I do to both sides?
Subtract 7.
Good. X equals 5.
Basically.
I have to find y. Go back to the original. I now know what x is. I now know what x is. So to find y, up here, it says take x and subtract 7. So I know what x is. X is 5. 5 minus 7 is what? Negative 2. So I have 5, negative 2 is my answer. You getting this? We need to do another one?
No.
I think we should. What?
Why did you divide it by x? 5.
Say again. Tell me which step.
On the last one, you divided by x, divided by 2. But you didn't do it.
Yeah, because I only have a 1 there. So if it's already alone, if there's a number in front of x, let's say this had been 3x, then I have to still go one more step. But because it was just 1x, x is already alone. You don't have to do that.
This,
Yep.
2, 5, 5 or 6, 2, 5.
Yeah, with the fraction one? Yeah. Okay. So this is like one of those ones that Mrs. McDonald was saying that you can, even the one isn't isolated, expression is isolated. So do you see the m over n here? So when I see an m over n, I can replace it with a 3. Can't see that. Sorry. Circle that m over n. Can you go to that expression next to it and circle an m over n for me? You can use substitution for just one variable or an identical expression, okay? So this really means 5 times m over n. Did you know that? That 5 up there really means 5 times m over, okay, good. So since I have that m over n there, and I know m over n equals 3, I'm not doing this. Perfect. What am I gonna put in the m over n spot there? Yeah, I'm gonna take it out. So instead of 5 times m over n, it's just 5 times 3, or 15. This one you didn't have to find m and n, it just asked you to find the value of 5 times m over n. It's easy? Okay.
Sounds way simpler than the other ones.
It was, but Shane asked, it is easy if you know what you're looking at, but Shane said it was hard because it's like, what is this fraction business in there? Mrs. McDonald, on this one, would you suggest that I move the a over b? No?
What did I just do? Yes, I did.
I have to get an a over b?
Yeah, I did that over the, I did change it to a equals ab,
Okay.
but then,
Do you see how I have an a here? I don't have an a over b, so I can't quite do that substitution. Can I do something to this tap to get a alone though? Couldn't I multiply both sides by b? All right, so on this one, what I'm going to do is I'm going to multiply both sides by b. And now that cancels. I get a equals 8b. Santos, does that make sense what I just did? Okay, tell me what to do now. I'm going to highlight something for you.
Oh.
Look at that a there. Look. Yeah, sub out the A and put 8B in its spot. So I still have that 3B minus 2 equals 8B. Do you guys want me to go through the solving steps again? Are you still rusty on that?
Yeah.
Like how I would solve this? Okay. I would first distribute. So I get 3B minus 6 equals 8B. So if they're on the same side, like this one up here, and this one up here, I just added them together because they were on the same side. When they're on different sides, I have to move one variable to the other side. I'm going to move the 3B by subtracting it. So left on that side, I have negative 6 equals, what's 8B take away 3B? 5B. And now I do have to divide both sides by 5. To get rid of that. So B equals negative 6/5. Or, you said that was negative 1.2? Okay, that's what B equals. How would you find A then? It says A equals 8 times B. Do I know what B is now?
Yeah.
Yeah, I know it's negative 1.2. Sal, since you have your calculator handy, can you tell me what that is? So A is negative 9.6 and B was negative 1.2 in that one.
It's just so much work.
Oh, Santos. So much
I
work.
don't get like when I'm
Oh my goodness.
That's why I go to the gym. Sorry.
I want to go to bed.
Let's do some jumping jacks.
I got gym next time.
Let's do some jumping jacks to wake you up.